Hi, this lecture is on Maxwell's equations, and it is to assist you in the FE prep for electromagnetics. This is just a slide that shows you all the different ways that electricity and magnetism have an effect on our lives. Just thought it was rather just a little interesting tidbit. Nothing informative other than just a neat little breakdown. Here that we're going to go into electromagnetics basic definitions that we need to understand. You have the electric field. Electric field exists in the presence of a charged body. Electric field intensity, a vector quantity, magnitude and directions. Think of like volts per meter. Magnitude of E proportional to the force acting on a unit positive charge at a point in the field. Direction of E, the direction that the force acts. The electric field is represented by drawing the electric displacement vector, which takes into account the characteristics of the medium within which the electric field exists. E, the electric conductive capacity or permittivity is related to the ability of a medium such as air to store electrical potential energy. And then there it is, the formulas for it are the actual values for vacuum, air, and then the ratio of epsilon. Now we're going to look at magnetic field. A magnetic field exists in the presence of a current. Magnetic field intensity, a vector quantity, magnitude and direction, amps per meter. Magnitude of H, proportional to the current. Direction of H, the direction that a compass needle points in a magnetic field. The magnetic field is represented by drawing the magnetic induction vector, which takes into account the characteristics of the medium within which the current flows. The magnetic inductive capacity or permeability is related to the ability of a medium such as air to store magnetic potential energy. Here again, we're looking at it in vacuum, air, and then the ratio of mu. Then here's the actual equations that make up Maxwell's equations. There's 4 of them. Gauss's law for electricity, Faraday's law, Gauss's law for magnetics, and then Ampere's law. And Gauss's law for electricity is just the electric flux through a closed surface is proportional to the charge enclosed. Faraday's law is changing magnetic flux produces an electric field. Gauss's law for magnetism is the total magnetic flux through a closed surface is 0. And then Ampere's law is electric current, and changing electric flux produces a magnetic field. Now we'll look at a little bit more of Gauss's law. It describes the relationship between the electric field and their sources, electric charge, which provides the electric field lines begin only at positive electric charge and end only at a negative electric charge. Gauss's law for magnetism states that there are no positive or negative magnetic charges, thus requiring a magnetic field lines to form closed loop paths. And then this slide just kind of breaks down Gauss's law of electric fields. Just tells us what everything is. You have the electric flux, and then you're looking at the tells you to sum up the contributions for each portion of the surface. I'm not going to read all this just because you can read it, and it's just kind of confusing without me being able to highlight each as I go through it. But again, this is just breaking it all down and telling you what each different symbol represents. Gauss's law for magnetism states that there are no magnetic charges analogous to the electric. Net magnetic flux out of any closed surface is 0. Faraday's law states changing magnetic fields caused voltage. This law is how generators, transformers, and also electrical motors are made, or the principle that they're based off of. And then here's Faraday's law. It just kind of shows you, you have a coil of wire moving into a magnetic field is one example of an EMF generated according to Faraday's law. The current induced will create a magnetic field which opposes the buildup of magnetic field in the coil. And then, it just has a little picture, coil of area with end turns. Again, it just kind of shows you, a little bit of how it's made, how they came up with it. Ampere's law states that for any closed loop path, the sum of the length of elements times the magnetic field in the direction of the length element is equal to the permeability time the electric current in closed loop. A flowing electric current gives rise to a magnetic field that circles the current. A time-changing electric flux density gives rise to a magnetic field that circles the D field. Ampere's law is the magnetic equivalent of Gauss's law. It is different in that it refers to a closed loop and the surface enclosed by it rather than a closed surface and then volume enclosed by it, as is the case with Gauss's law. Consider a closed loop, not necessarily a circle, which is broken into small elements of length dl with a magnetic field at each element. And then you have a little picture. The sum of over elements of the component of the magnetic field along the direction of the element times the element length is proportional to the current that passes through the loop. And then here's a couple helpful links. They're both about 5 minutes apiece, and they just break it down, do a real good job of explaining it. Then here we go through some problems. I'm going to let you kind of follow through those on your own. There's no point in me reading them out. If you have any questions, just feel free to use the discussion board and please ask. Thank you very much.